Okay, this says which of the following integrals converge. And so once again, we recall our p-series properties, which is that like, so more generally, as long as a is I usually use, textbooks might put a 1 there, but any number bigger than 0 makes this true. So anything of this form, okay, it's going to converge or diverge depending on the value of p. So it's going to diverge if those are the p-values, or it's going to converge if p is bigger than 1. So we want to know which one of these converge. We got to compare them to a p-series that we recognize. So if I look at 1, for example, remember this one's 1, this one's 2. So if I write 3 to infinity of, actually I'll write, so I'm just going to save on some writing. That 1 behaves like, going to behave like a p-series. And now we just got to go strip out the highest degrees here. So there's the highest degree in the top, and the highest degree in the bottom is that one. Careful because they're written reversed. Okay, in the long run, that function behaves like this, like x to the 100 over x to the 100. I'm just going to do some scrap over here. X to the 100 over 11 x to the 103, which is equal to 1 over 11 x to the third. The 1/11th doesn't really matter, so you can ignore it or not. That does not affect the converging or diverging behavior, so because it can like factor out here. So it's going to behave like this, and then you just recognize by it above that converges, right? So if that converges, so is number 1. So anything that doesn't have number 1 is out. Okay, and so 2, we'll do the same sort of thing with 2. 2 is 4 to... Okay, that's going to behave like the integral from 400 to infinity. Okay, so let's go up here. So it's going to behave like x to the 16th divided by, so just be careful because down here it's like x to the 1.5 to the 11th. And so those multiply. So 11 times 1.5 is, it's like 11 times 3 halves, right? So that's 33 halves. You can call it 33 halves or 16 and a half. Okay, and so so this is now, 1 over x to the 0.5. If you look above, that means it's going to diverge. So 2 is out. So it can't be all of them. It can't be that one. So now, it's A or F now. So we look at 3. And again, we got to kind of see what that behaves like. Okay, so that's going to behave like 1 to infinity of, so we go up here. So 7, so this is just going to test a little bit of the arithmetic. The best way to do this is just subtract exponents, right, when you're dividing. So it's like x to the 7/6. So x to the 7/6 divided by x to the 8/3 is the same as x to the 7/6 minus 8/3, which is x to the 7/6 minus 16/6, which is x to the negative 9/6, which is 1 over x to the 9/6, but 9/6 is 3 halves. So now we go, so it's going to behave like that. Okay, and then according to, so that's bigger than 1, so it's gonna converge. I should write diverge here, right? Diverges. This is gonna converge. Okay, so 3 is gonna converge. So that gives us F.